Okay. So let's just kind of talk about what we did last class, or the last few classes. So do you remember the first day we did limits? We were looking at graphs, checking the left and right side, finding the answer, right? Then we did it without the graphs using the equations. Do you remember? Okay, then last time we did the asymptotes with a graph. So today we're going to do the asymptotes when you have just the equation. Okay. So you actually learned all these rules last year when you were in pre-K. Okay, even if you did on-ramps, regular, it doesn't matter. Okay, the way that you tell if your graph has horizontal asymptotes, that's the kind that we're finding today, is based on which part of the fraction is bigger. So if you were in my class, we did Bobo, Bot, and Betsy. Does anyone else from another class remember that? No, no little cute acronyms. Okay, that's okay. So here's how it works. Okay, I think it'll look familiar even if your teacher didn't use that whatever thing. If the denominator, that's the bottom, is greater than the numerator, we're going to call that a Bobo. Okay, and here's what that stands for. The bigger power is on bottom. So the ends of the graph go to 0. Okay, write that down. Bobo means the bigger power is on bottom and your ends of your graph will go to 0. I'm going to give you an example and then a sample graph. Okay, so we're going to do y equals 3x squared plus 5 over, let's do 1x cubed plus 8. What we are comparing is the degree of the polynomial. Degree means the power. So my power on top is an x squared. On bottom, it's an x cubed. Which one is bigger? The one on the bottom. That's what makes it a Bobo, okay? Now, the way the graph could look, not for that exact equation, but for any Bobo, okay, is that your middle can do whatever it wants. So I'm just going to go ooh, like that, okay? But then the ends of the graph, as you go towards infinity and negative infinity, should curve off to 0 like this. Okay, if your graph is a Bobo, okay, then the ends of your graph are going to curve to 0. Okay? But what happens in the middle, who knows? But you know that the ends of the graph will do that. Okay, let's go down to part B. Okay, bottom is if it is bigger on top. So put BOTN. Okay, that stands for bigger on top. And then the N means that you have no horizontal asymptote. Okay, so a lot of times I'll say the N is a none. Okay, so bigger on top, none. Here's what that could look like as an equation. Y equals, let's put the 3x squared plus 5 on the bottom. And let's put the x cubed plus 8 on top. So then you would be looking at your powers, okay, or your degree, that's what that's called. And you would say, I have an x3 versus an x2. The x3 is the bigger one. It's on top. That makes it a bottom, which means it's no asymptote. Here's what that could look like. Okay, draw a little crazy guy in the middle. And then remember that if your graph doesn't have an asymptote, that means it can't flatten out. So maybe one end is pointed up and maybe the other end is pointed down. Okay, but for a no asymptote graph, your ends have to be up or down. They can't be flattening. Okay, and that will happen anytime that the top power is bigger than the bottom power. Okay, last option. Okay, is a Betsy. Okay, so here are your options. Either the bottom is bigger, it's bigger on top, or Betsy, do you remember what it stands for? Michelle, Annie? Both, yes. Yeah, very good. Okay, I'm impressed you remembered that much. Both equal. Divide. Okay, I'm going to put divide coefficients, but that is the same. Okay, because the coefficient is gonna be the constant in front of the x. Okay? So both equal, divide the coefficients. Here's what that means. If you have an equation where your top and your bottom powers are equal to each other. So let's say that you have y equals 10x cubed plus 8 over 2x cubed plus 7. First question I would ask you, is it bigger on top, bigger on bottom, or are they both equal? You would say both equal, because what's the power on top and on bottom? They're both x3. That means that it's a bed C. You're going to divide the numbers in the front, the coefficients, to find out what your ends flatten out to. So in this case, I would do 10 divided by 2. What is that? Then y equals 5 is going to be where your ends curve off. So let's draw a graph. Little crazy guy in the middle. Remember, this doesn't tell us anything about what happens in the middle, but then the ends of my graph are going to flatten out to 1, 2, 3, 4, 5. We'll say y equals 5 is here. And then your graph would have to approach that value at the ends. Just like that. Okay, but Bobo, Botan, and Betsy only help you know the end behavior. They don't help you with all the other stuff in the middle. Okay, so let's do some examples. Okay, take a look at number 1. What is the highest power of x that you see in the top of the fraction? Okay, it's going to be an x to the 1. What's the highest power on the bottom? X to the 2. Which one's bigger? Is it a Bobo, a Botan, or a Betsy? Bobo is correct. And remember that for Bobo, it means bigger on bottom goes to 0. So put equals 0. And I know that my graph at the ends would look like this first graph we drew, where it curves off to the x-axis. Okay, second one, highest power on top. What number? X to the 4. On bottom, x to the 2. Is it a Bobo, a Botan, or a Betsy? Very good. It is a Botan. And if it's a Botan, what does the end stand for? No asymptote, then the ends curve off to, we don't know, DNE. Okay, but we know they're not approaching a number. One more left like this, very predictable. Okay, we had a Bobo, a Botan. What do you guess this one? Probably it's a Betsy. Okay, because I have an x2 versus an x2, that's both equal. Then I divide the numbers in the front. What am I dividing? 5 divided by 7. That won't really reduce. So we're just going to box that as our answer. Okay, but if it was like 5 over 15 or something that could reduce for your delta math, make sure you do it. Okay, second row. Okay, give that a shot. Remember, you're looking for the highest power on top compared to the highest power on bottom. Maybe I'll call on one of you. Would you like that? Michelle, you have all the Bobo Botan Fancy experience. Okay, number 4. What would you have put? Which one? Yeah, oh, no tricks for you. Okay, now you might have put Betsy because it's an x3 versus an x3. But remember, you don't want whatever's in front. You want whatever's biggest. Okay, so the top is an x to the what? 5 versus an x3. That is a Botan. Okay, good job. That's going to be DNE. Okay, then let's do for the next one. Dawson, what did you put for number 5? Is it a Bobo, a Botan, or a Betsy? It is a Betsy. Very good. And what numbers did you divide? 3 divided by 5. So the answer is 3/5. Is that correct? What are we missing? Huh? Okay, good. I tricked you. Haha. It's 3 divided by -5, right? Because it's a minus 5x, which means we need that negative there. Okay? Do you hate when I call on y'all? Does it make you nervous? Or do you like it? Linus, number 6. Bobo, Botan, Betsy. Button, which means what do I put for the limit? Very good. Okay, turn to the next page. Okay, this packet you'll notice has approximately 9 billion examples. So we're gonna skip the next row and start with number 10. Notice that for number 10, 11, and 12, okay, I'd like for you to notice that you still have polynomials, but they're in factored form. What that means is they're broken down into parentheses. Okay, it doesn't matter though. You just need to find out what it would be if it wasn't factored. So for example, on number 10, what is 3 times 2x? Okay, 6x. And then on the bottom, I have a 2x times a 3x. Would that also be a 6x? 6x squared, very good. So just make sure that you times it out before you compare. Now, one more thing. Do you remember how I'm always just picking the highest power on top and on bottom? What that means is I'm not gonna times out all the rest of it. I really only care about the biggest power would be the 2x times the 3x. That gave me the 6x squared. I'm not also gonna times by the 1 because I know it will be a higher power than x squared. Okay, then what is that? Bobo, Botton, or Betsy? Bobo is correct. Okay, do the same thing for the next two. Okay, so you're gonna times out the highest power on top. You can times out the whole thing if you want to, that's not wrong. But just to save you a little trouble, you only need to times the x's together. Okay, number 11, Lamek, can you tell me your top highest power, what that term was? Correct. What did you also get on the bottom, please, sir? 12x. Okay, 12x squared, which makes this a Bobo, a Botton, or a Betsy? Beds. Oh, should be Betsy, because remember, x squared versus x squared, that's a tie. Okay, no. Okay, then 6 divided by 12, what do we get for that? 1/2. Okay, and make sure that for your delta math, if you had put 6/12, it would count it wrong. You do have to reduce. Okay, one more like that, number 12. Just tell me out loud, how many x's are on the bottom? X to the second power, or x squared, which means this is a button, which means my limit is what? DNE, very good. Okay. We're gonna skip, we're gonna come back to this, but I want to go to the next section. So in pre-cal, you only should have done this with polynomials. Polynomials are things like x squared, x cubed, x to the 5th, whatever. So now we're gonna bring in all the other functions. So do you see on 10 through 15, you've got some cosines in here, some natural logs, you've got a 2 to the x down there, and e to the x. So all of these functions can be arranged from smallest to biggest. Okay, so let's start with the smallest classification. If you have sine or cosine, or any other constant, those are the weakest of all of the types of functions that you'll see. Okay, after sine, cosine, and your constants, the next one is going to be all of your logs or natural logs. Okay, because remember, a natural log is a type of log. Okay, so that's going to be your second classification. They get more powerful as we go. The next one is going to be your polynomials. And then polynomials are sometimes called powers, but this is like x squared, x cubed, blah, blah, blah. Okay, and then the biggest classification is going to be exponentials. And the difference between a polynomial or a power and an exponential is where the x is. So what I mean by that is that here for a power, it's x squared, and exponential would be like 2 to the x or e to the x. But do you see the difference that for an exponential, your x is the exponent, versus for a power, your x is the base. Are we all good with that? Okay, so 4 classifications. Could be sine, cosine, or a constant. That's the weakest. Then your logs, then your polynomials, then your exponentials. Let's do some more examples. Take a look at number 10. On top, the biggest thing I have is sine or a constant, which both fall into this category, yeah? E to the x counts as a what? Exponential. So if my top is a category 1 and my bottom is a category 4, which one's bigger? Is it Bobo, Botan, or Betsy? Think about it. It is Bobo. Okay, because where was the exponential? The exponential was on the bottom. And then this one we'll say was sine, cosine, constant. And so if I'm comparing those, this is the weakest of the choices. This is the most powerful. Then the bottom wins. It's a bigger on bottom and it goes to 0. Do you get what we're doing there? Okay, so now take a look at the next one. I want the biggest thing on top versus the biggest thing on bottom. Now, on the top, I have a 5x cubed. That's a power, or I have a +1 is a constant. Which of those is the biggest for the top? The power. So I'm going to circle the 5x cubed versus on the bottom, I have an ln x and a +2. Who's the biggest out of those? ln x is a log. That's going to be the biggest. And then when I versus, I'm looking at 5x cubed versus ln x. Who's going to win? 5x cubed. And where is it? On the top. That means that this is a Botan, which means that it is a DNE for your final answer. Okay, take a look at the next one. Cosine x plus 2x versus 5 minus ln x. Okay, on the top, cosine x is one of your trigs. 2x counts as a polynomial, even though it's just like a regular x, not like squared, that still counts as a polynomial. So who would I circle on the top? Who's bigger? Polynomial 2x is the biggest. Versus on the bottom, I have a 5 and an ln. Who's going to win? ln. And then between those two, which is more powerful, the top or the bottom? Top is a power. Power beats log. So this is a Botan, which means that it's going to be DNE. Are you getting the idea here? Okay. Number 13. What type of function is the top? Okay, it is a log. Someone in the other class said, well, what about the 20x plus 7? Isn't that a polynomial? What is it inside? A log. This is a log. Okay, it doesn't matter what's inside it. If it's inside log or ln, then it is an ln or log type, which is this category. Versus, yes, Benji?
So the 2x, like, that is a polynomial.
Uh-huh. Because it's like a 2x to the 1, basically, and 1 counts as a power. Okay, taking a look at this bottom now, who wins, 10x or 2 to the x? 2 to the x is what type? So if I have a log on top versus an exponential on bottom, which one's more powerful? Bottom, so it's a Bobo, which means that it goes to 0. Try the next two. Okay, number 14. Sasha, will you tell me your answer, please? Uh-huh, which means it goes to 0. Very good. And then let's go with Annie for number 15. What'd you put? Bobo is correct. Now, for Bobo, some people have, sometimes will say, but wait, aren't they both powers? Yes, but one of the powers is bigger than the other, right? So if I have a 2x, that's a first power, versus an x to the 100, that is still a Bobo, and he's exactly right. We're going to put 0 for that. Questions on that? Okay. Go ahead and turn the page. Okay, there are three types of functions. This is where it's gonna get, I want you to do your best to stick with me here, okay? So there are three types of functions where whether you're going to infinity or negative infinity, it actually matters. All of the other questions we've done, you may not have even noticed it, but do you see how some of them were going to infinity versus this one went to negative infinity? Did we do anything different though? No. So normally for 90% of the functions you're gonna see, infinity, negative infinity, doesn't matter, you're doing Bobo, Bot, and Betsy. There are three equations where it matters, and they're right here at the top. The first one is absolute value, then square root, then exponential. We're gonna go each type one at a time. Okay, we're gonna start with absolute value. Do x to infinity exactly the same. Is this a Bobo, a Bottom, or a Betsy for number 16? It's a 4x on top versus an x on bottom. What type? It is a Betsy because they're both x's, which is a power of 1, so they're the same. Then I would do 4 divided by what on bottom? That's a 1x, right? So 4 divided by 1 means that this goes to 4. Okay, now let's talk about what if it's a negative infinity. Okay, I want you to think about just the sign because it's still going to be 4 over 1. Here's where it's going to be different. Okay, track with me here, and I think this is really not too hard, it's just kind of weird. If you are going to negative infinity and you plug it into 4x, the negative is going to now make it a negative 4x. Okay, but then I'm going to take the absolute value. How is the top 4 going to come out? Positive, because what do absolute value bars do? They always turn everything inside them positive. So my top is going to be a +4. But now let's think about my x on the bottom. I'm taking a negative infinity and I'm plugging it in for x. What's going to happen to the 1 in front here? It's going to turn out to be a -1. And if I do a +4 on top divided by a -1 on bottom, because the negative is going to come off of this infinity, my limit is actually going to be -4. Okay, but remember, there's only 3 types of equations. You have to worry about them coming out different. Okay, let's look at number 17. X to infinity, I do my normal rules. Is it a Bobo, a Bottom, or a Betsy? For 17. It is a Betsy. I have a 2x squared over a 1x squared. 2x squared over 1x squared. I divide those numbers in the front. 2 divided by 1 gives me what? 2 is correct. But then for the next question, I have the exact same equation, but I'm approaching negative infinity, and I see that I have one of my 3 weirdos, right? I have an absolute value. So I'm going to still put 2x squared over 1, but now I'm going to have to think about what happens to the negative. Now, if I take a negative infinity and I square it, what's going to happen? It'll turn positive. And then I'm going to put it in absolute value bars. It's going to still be positive. So put a plus in front of your 2 on top. Okay, now let's talk about on the bottom. I'm taking a negative infinity and I'm going to square it. How's the 1x squared going to come out? Positive or negative? Also positive. And +2 divided by +1 gives me 2. So notice that sometimes it'll come out to 4 and -4, but then sometimes they come out the same. You just have to check. Okay, so try the next one. Think about your signs. For number 18, you have a 2x cubed over an x cubed. What is my first limit going to be? 2 is correct. Okay, now check the second one. Think about the sign. So it's 2x3 over x3. Okay, if I take a negative infinity and I cube it, what's going to happen? It'll still be negative until what? Absolute value bars will turn it positive. Okay, now let's look at the one on the bottom. I'm gonna take my negative infinity and I'm gonna cube it. What's gonna happen on the bottom? It's gonna stay negative. And now I have a 2 divided with a -1 gives me -2. Okay, so sometimes these come out the same, sometimes they come out to be opposites. Okay, so your first type is absolute value. If it shows up and you're going to negative infinity, take a little bit of extra time, but other than that, the positive infinities are the same. Okay, go down to the next section. We're going to cover square roots. Okay, for square roots, you're going to do almost the exact same thing. Going to infinity, you're going to just simplify the highest power. So in this case, do you see that we have a square root of a 9x squared? What is that the same as? Ignore the rest of it, just the 9x squared. If I root that, what is that the same as? 3x. So really, I have a 3x over 2x. Okay, and remember, plus ... We don't care about the rest of the crap in there. We just care about the biggest thing. So if it's a 3x versus a 2x, Bobo, Botner, Betsy. Betsy, and the Betsy comes out to 3 over 2. Okay, Betsy is 3 over 2. Now let's say I'm going to negative infinity. Okay, for negative infinity, this is still going to be a 3x over 2x, but I have to check the signs because it's one of your 3 weirdos. Okay, if I have a negative infinity and I square it, how's the top going to come out? Positive or negative? Put a plus there. What about if I put a negative infinity into a times 2? Now the 2 is going to be a what? -2. And if I have a positive 3 divided with a -2, my answer is going to come out to -3 over 2 for the other limit. Okay, but for most of your equations, you don't even have to check. It's just if it has an absolute value or a square root at this point. Okay, number 20. Simplify the biggest thing under the root. What is the square root of x to the 4th?
4x.
Okay, it would be 4x squared is correct. Over what on bottom? 3x squared. And so we see that's a Betsy, which means we're going to divide the coefficients. We're going to get 4/3. If x is going to infinity, you don't have to worry about checking the sign. It's only for negative infinity for this second part. So I'm still going to have 4x squared over 3x squared. But I'm going to check what my negative does for my infinity. If I do a negative infinity and I square it on the bottom, how's that going to come out? Positive. And then what about on top? If it was to the 4th power, it would also be positive. So in that case, they both came out to 4/3. Try the last one. Okay, try number 21. Can someone tell me the root of 25x6? 5x3. Versus on the bottom, I'm going to have 7x3. And now quick question, why don't I even care that the log's here? Because who's more powerful out of my choices? The polynomial wins. So even though this is here, I don't even care. I'm looking for the biggest thing. Polynomials beat logs. Okay, from here, I know it's going to be 5/7 because it's a Betsy. Now let's do my negative infinity. 5x3 over 7x3. Okay, give you another minute to think about it. Will it come out to be positive or negative for your final answer? Oh, you don't want to say? It is going to be negative. Okay, let's talk about why. When I take my negative infinity, if I cubed it, would it get to keep its negative? Right here on the top? Okay, but remember, it wasn't originally a cube. What happened first? It was a 6 power. Does it get to keep its negative if this is an even? No, so the top came out positive. But the bottom, since it's a cube, you cube something negative, they cancel out in twos, you'd still have a negative left over. So it should have been -5/7 for that last one. Okay, does that make sense? Okay, I would really like, we have to do one more page. Can we do it? Are we too tired? Well, if we say no, we'll do delta math and then have to come back and finish it at the end of the period. Just knock it out, okay. Just one more page. Okay, turn the page. Okay, the last thing we're gonna cover today, we covered your square roots and your absolute values. The last thing we have to cover is your exponentials. This is the third of the weirdo types where you have to check infinity and negative infinity separately. Okay, here's why. Draw a graph of e to the x. Do you remember what e to the x looks like? It flattens out on which side, left or right? Left is correct. Hi. What's up? This should look like this. Okay, so draw that. We'll do y equals e to the x. You can just ask me.
I did this to like email you or something.
Yeah, just email me and say I finished the late homework and I'll take the penalty off. You want me to reset it? Okay, put that in the email too, and I'll do it as soon as I'm done teaching them.
Thank you.
Okay, so look at the graph of e to the x. Do you notice that on this side you have an asymptote, but on this side you don't? Okay, that happens because of this property. If you have a negative in your exponent, do you remember that that means you can bring that term down into the bottom of a fraction? Yes, do you? No, maybe? Okay, I'll just tell you it's true that if you have a negative power, that means that that term really belongs in the bottom of a fraction. So same thing if it's in the bottom and it has a negative exponent, I can bring it up to the top and it would just be b to the x. So a negative in your exponent is going to slide that term into the base of a fraction. So let's look at your two limits, first to infinity, then to negative infinity. I need this to be a fraction. Otherwise, how can I Bobo bot and Betsy it? So I'm going to put this over 1. And then I'm going to ask myself, what's bigger? The e to the x on top or the 1 on the bottom? Who wins? E to the x, which is where? On top, which means that this is a bottom, which means that the limit is d and e. And if you look at your graph, as you go to infinity, that's this right end. Is it d and e? Is it going up forever? Yes. Now let's look at our left side. X is going to negative infinity, which is going to plug in where the x is. Now I have a negative that's dropping into my exponent on my e. So that is going to change your e to the x to be a 1 over e to the x. Okay, think about why that is. Let me say it one more time. I have a negative from my infinity that's going to rub off on the x, and a negative in the exponent drops it into the bottom of a fraction. Now who's bigger? Is it a Bobo, a Botan, or a Betsy? Now it's a Bobo, which means that it's going to 0. Okay, and the only type of function that that happens for is e to the x. And it's because you have a limit on one side, but then it's a d and e on the other. So let's work these 8 examples, and then we'll be done with notes for the rest of class. Take a look at 24. X to infinity, what's your biggest thing on top? We're just going to circle the biggest thing on top and the biggest thing on bottom. What is it? E to the x is correct. Circle it for me. On the bottom, what's the biggest thing? 3x to the 4. Out of those, who's bigger? So it's bigger on top, none. So we're going to put d and e. Now look at 25. X is going to negative infinity. And when the negative infinity pops into the e to the x, here's what it does. Now it's a 1 over e to the x plus 10x to the 4 over 3x to the 4 plus 5. So as soon as that negative infinity hits the e to the x, now it's a fraction and it's not exponential anymore. So now that I'm looking at the top, who's bigger? Now 10x to the 4 is the winner. Okay, because this doesn't count as exponential anymore. So now it's going to be this versus this. Is it a bobo, a button, or a bedsy now? Now it's a bedsy. What am I dividing? 10/3 is your answer. Okay, so one side came out to be DNE, the other side came out to have a limit. Let's do 26. X is going to infinity. What's your biggest thing on top? 3x to the 4. What's my biggest thing on bottom? E to the x. And if the bigger thing is e to the x on bottom, what does it go to? 0, and it is a bobo. Okay, now check the negative infinity side. As soon as my negative infinity hits my e to the x, what happens to that term? It's going to turn into a little fraction. So now it's 3x to the 4 plus 2 over 1 over e to the x plus 10. And now when I'm picking my biggest thing on top and my biggest thing on bottom, it's 3x to the 4 versus just a regular 10. Okay, because this doesn't count as exponential anymore. Once you fraction it, it loses. So my 10 versus my x4, what's that going to be? Bobo, bottom, or bedsy? It is a bottom. Very good, which means it's DNE. Okay. 2 more rows left and then we're done. 3x plus 9 over e to the x minus 6. What's your biggest thing on top? 3x, which is a power or a polynomial. On bottom, I have an e to the x, which is exponential. Bobo, bottom, or bedsy? It is a bobo, which means this goes to what? 0, right? Take a look at 29. X is going to negative infinity, and you have one of your weirdos. We don't have any absolute value or square root, but we have an exponential. What happens to the exponential as x goes to negative infinity? It does what? Makes it a fraction. So now it's 1 over e to the x minus 6. And then when I look at my top and my bottom, my biggest thing on top is still 3x. But now my biggest thing on bottom is just a minus 6. Who wins, top or bottom? So now it's DNE. Okay, or it's a bottom. Okay, 2 more left. First one, number 30. Biggest thing on top is a log. What's the biggest thing on bottom? Exponential. Who's bigger, a log or an exponential? Exponential is bigger and it's on the bottom. That makes this a bobo. And if it's a bobo, then the ends go to 0. Okay, now go to 31. X approach negative infinity, and I do have an exponential. What happens to my 4 to the x? Now it's a what? 1 over 4 to the x. So if I have a 6 log x on top over a 1 over 4 to the x plus 10, what is my versus now? The top is classified as a what? Log, right? And the bottom is classified as a what? That would be a constant. Then who's bigger? Top. So now it's a bottom, which means it's DNE. Okay, that was kind of a lot, but do you feel like you can do it? Okay, pull out your Chromebooks, log into Delta Math for me, please. There are some sections you can't do, but they're all at the bottom. The first 3 you should be able to do.